Hey guys, so today we are going to be talking about limits. So we are going to start with this function right here, f of x. And using f of x, we are going to plug in 1. So I am going to take this function right here, and I'm going to have 1 squared minus 1 over 1 minus 1. And you'll notice that when we do that, we end up with 0 over 0. And this is called indeterminate. And it's kind of tricky. It doesn't mean that our answer is 0. So we kind of need to look at it and see what's happening here. So instead of directly plugging in 1, we're going to try approaching it closer and closer from the left side and from the right side. So in order to do that, I'm going to make a table, and I've got my x and my f of x. So I've got my table here, and I'm going to use the x values of 0.9, 0.99, and 0.999. So let's come to our calculator and plug those in. Okay, so in my calculator, I'm going to plug in 0.9 squared minus 1 over 0.9 minus 1. And that gives us 1.9. So in my table right here, I'm going to put 1.9 and then do the same thing with my 0.99. So alpha y equals enter. To get a fraction, I'm going to have 0.99 squared minus 1 over 0.99 minus 1. And that gives me 1.99. And the same thing again with 0.999. And this time it gives me 1.999. So you can see that as our x values are getting closer and closer to 1, our f of x values are getting closer and closer to 2. So now we're going to do the same thing, but going from the right. So I'm going to set up a table. And this time I'm going to use numbers that are bigger than 1. So let's do 1.1, 1.01, and 1.001. So you guys go ahead and plug those into your calculator. We're going to pause here and let you get those numbers, and then I will tell you what they are in a second. All right, so when you plug these into your calculator, you should get 2.1, 2.01, and 2.001. So once again, our x values are getting closer and closer to that 1, and our y values are getting closer and closer to 2. So we can say that as x gets close to 1, then the function gets close to 2. And so what we're talking about here is when x equals 1, our answer is indeterminate. Our answer is that 0 over 0. We don't know what that is. But we can see that it's going to be 2 based off of the tables that we just did. So we can't say that the answer is 2 because the answer is indeterminate. So instead, what we're going to use is a limit. So we're going to say the limit of the function is 2. And so that's going to be written just like this right here. The limit as x approaches 1 of our function is equal to 2. So it's a special way of saying ignore what happens when we get there. But when we get closer and closer, the answer is going to get closer and closer to 2. So if you're looking at it on a graph, it's when you have a hole in your graph right there. So if you see right there, there's a little bitty hole. It's kind of hard to see. So at x equals 1, there's not actually a point on the graph, but our graph is getting closer and closer to the point that would be 2. So there's no value at x equals 1. So there's no value at x equals 1, but if there were a value, it would be 2. Oh, sorry guys, my pen is going crazy today. It would be 2. Okay, so right here I've got your textbook definition of a limit. I literally pulled this from the textbook that we use for this class. So what it says is that when the x values are approaching x equals c, so that's this part right here, from either side of x, the y values are going to become arbitrarily close to a certain number. And that number is L, so that's what our limit equals. So the limit as x approaches c is L. And so limits are often used for difficult functions like the one that we just looked at, but they also can be used for easy functions too. So an example, right here I have the limit as x approaches 10 of x over 2. So all I'm going to do is plug in that 10. 10 over 2 gives me 5. So my limit as x approaches 10 is just 5. So that's an easy one. They're not always complicated problems. So let's look at a graph and look at how our limits work there. So number 1 says the limit as x approaches 10. So as x approaches 10, which is right here, our limit is this point, which is 3. 2 says the limit as as x approaches 7 of f. So that's this point right here, which is a -1. So notice there's not a point there, but we're looking at where the graph approaches. So we're looking at what the graph gets closer and closer to. So even though it's a hole, that's okay. And then the limit as x approaches 0. So that's this right here. And if you notice on all the other ones, our graphs pointed very nicely from the left side and the right side to a specific point. From the left side and the right side. But if we look at this one, when we're coming from the left, it doesn't match up with what is coming from the right. So this is where we say that there is no limit, or the limit does not exist. Which we also write as D in E. So now when you watch Mean Girls, you know what she means when she says the limit does not exist. All right, let's keep going. Let's look at some more examples. So number 4 says the limit as x approaches 2. So the first thing that you should always do is plug in the number and see if you get a value. So let's look at 2 squared minus 3 times 2 plus 4. So we're looking at 4 minus 6 plus 4. So 4 minus 6 plus 4 is going to give us our value of 2. So the limit right here is just equal to 2. So that one was nice and easy. We didn't have to do anything like a table. You could just plug the value in and find what the limit is. All right, let's look at 5. Let's come over here and see what happens when we plug in 2. We're looking at the limit as x approaches 2. So if I have 2 squared plus 2 minus 6 over 2 minus 2, well, that's going to give me 4 plus 2 minus 6 over 0, or that gives me 0 over 0. And that's our indeterminate form. So we've got to play around with this one a little bit to get our answer. So what I'm going to do is I'm going to factor the top right here. So I'm going to have the limit as x approaches 2. I'm still going to have my x minus 2 on the bottom, but I'm going to factor out the top. And so there are a bunch of different ways that you can factor. I use the big X method. So if we have our big X, we're going to have a -6 on the top and a 1 on the bottom. So what are two numbers that multiply to give me a -6 and add to give me 1? And so I know that I'm going to have a 3 and a -2. So I'm looking at X plus 3 and X minus 2. And you'll notice that my X minus 2 on the top and bottom can cancel out. So that means that I'm looking at the limit as X approaches 2 of X plus 3. And that one, when we plug in 2, we get 2 plus 3, and we get that our answer is 5. So sometimes you can factor and cancel things out to make your limit a little bit easier. All right, let's look at 6. The limit as X approaches 3. So let's start by plugging in 3. That means I'm going to have 3 over 3 cubed plus 2. So 3 over 27 plus 2, or 3 over 29. And that is a number, so that is our answer there. We don't have to do anything else. So it's 3 over 29. And let's look at 7. All right, for number 7, we're looking at when X approaches -1. So I'm looking at -1 cubed minus -1 squared over a -1 minus 1. So -1 cubed is still -1, minus -1 squared is a +1, and then -1 minus 1 gives me a -2. And that's the same thing that we have on the top. So -2 over -2 just gives me 1. So my answer for number 7 is that the limit is equal to 1. All right, let's look at number 8. For this one, we are looking at the limit as X approaches pi over 2. So we are looking at the sine of pi over 2 over pi over 2. And you should remember from pre-cal that the sine of pi over 2 is equal to 1. So I'm looking at 1 over pi over 2. And remember, we can't have a fraction in our denominator. So I'm going to flip it and bring it up here. So it's going to be 2 over pi times that 1. So our answer is just 2 over pi. So the limit is 2 over pi. All right, let's look at 9. For number 9, we're looking for the limit as X approaches 2. So I have 2 over 2 minus 2, or I end up with 2 over 0. So having that 0 in the bottom, we cannot divide by 0. And this one, there's not anything that we can factor out. So for this one, we're going to need to do a table. So let's start with our numbers that are less than 2. So I'm going to do 1.9, 1.99, and 1.999. All right, so looking at our calculator, we're going to have alpha, y equals, enter, 2 over 1.9 minus 2. And that gives us a -20. And let's do the same thing with 1.99. This time we get -200. And let's do 1.999. that gives us negative 2,000. So when we're looking at this one, our x values are getting closer and closer to 2, but our y values are just getting bigger and bigger and bigger. So our y values are getting closer and closer to a negative infinity. They're just going to keep getting bigger and bigger and bigger. All right, let's look at the right side. So now we're going to do the same thing, but we're going to pick numbers that are bigger than 2. So let's do 2.1, 2.01, and 2.001. So we're going to pause here, and you're going to plug them into your calculator on your own. All right, for 2.1, you should get 20. For 2.01, you should get 200. And for 2.001, you should get 2,000. So in this case, as our x's get closer and closer to 2, our y values are going off to positive infinity. So what that means is that we're going to have a graph over here, and at 2 right here, we're going to have our function going off to negative infinity when we're coming from the left, and then when we're coming from the right, it's going to go up to positive infinity. So right here, we have a limit that does not exist. And let's look at 10. All right, for 10, we're looking for the limit as x approaches 1 of the natural log of x. So we are looking at the natural log of 1, which you should remember from Algebra 2 and pre-cal, that the natural log of 1 is just equal to 0. So our limit here is 0. And our last problem for the notes. The limit as h approaches 0 for this function. So let's plug in 0 and see what happens. So that means that we're going to have x plus 0 squared minus x squared over 0. And we end up with 0 over 0. So for this one, what we need to do is we need to go ahead and multiply out on the top. So if I have an x plus h squared, that's the same thing as x plus h times x plus h. So when I FOIL that out, I get an x squared plus xh plus xh plus h squared, or you're going to end up with an x squared plus 2xh plus h squared. So that means that I'm looking at the limit as h approaches 0 of x squared plus 2xh plus h squared minus x squared all over h. So on the top, I have a positive x squared and a negative x squared that are going to cancel out. So now I'm looking at the limit as h approaches 0 of 2xh plus h squared divided by h. And on the top, I have an h in both terms, so I can factor that out. So I'm going to have the limit as h approaches 0 of h times a 2x plus h over h. So those cancel out. I'm looking at the limit as h approaches 0 of 2x plus h. And so now I can just plug that 0 in, and I'm going to have 2x plus 0, which just gives me my answer of 2x. All right, that is all that we have for our notes for this section. You do have a worksheet that you're going to have to do for homework. And don't forget about all of these reminders over here that we talked about at the beginning of our Zoom meeting. All right, get started on that homework.